Hi everyone, welcome back. In this video, I'll be explaining you the lead code problem called successful pairs of spells and potions. So, in the problem statement, we are given with the two arrays called spells and potions. It contains integers and an integer variable called success. So, we need to compute the product between the numbers in spells and potions. And if the product is greater than or equal to success, then we need to return the. We need we need to count the pairs which is having the product greater than success, and we need to add them into the array. Let me explain you. So this is the array we got. So if we carefully see here, 5 computed by 1 will return 5. Uh, 5 with 2 give 10. 5 with 3 gives 15. 5 into 4 gives 20. And 5 with 5 gives 25. So we need to check how many numbers are greater than 7. They are 1, 2, 3, 4. So we need to add the count of the numbers which are greater than 7. So similarly with 1 we'll get 1, 2, 3, 4, 5. If we see here, none of them are greater than 7. So we need to add it to 0. If we have multiplication with 3, we'll get 3, 6, 9, 12, and 15. So the count of numbers which is greater than 7 are 1, 2, 3. So we need to add 3 in the array and we need to return this array. So if we see here, 403 is the answer written. So brute force will be, we need to iterate over the array spells, and in the nested loop we need to iterate over the array portions, and we need to compute the product, and we need to compare the product with this success, and we need to count each and every number and add it to the array. So actually brute force will phase for this solution as it is a medium level problem. For this we need to add binary search. Why binary search? Because here order of the array is not important. We need to just compute the numbers which is greater than the product. So we can use binary search like this. Let me explain you. Mm, So if we see here, we need to sort the portion array. So here portion array is already sorted. Let me show you. So this is the portion array. In order to compute, we need to apply binary search. At first, low will be pointing to this index and high will be pointing to this index. So we need to compute the mid. We'll get mid around here, and we need to check. We need to multiply the array of 5. Suppose let's take it the first index of spells, nothing but 5, and we need to multiply with 3. We'll get 15. We need to compare it with the success. So if it is greater than, we need to check the number which is just greater than uh, the success. For that we need to move this mid pointer, high pointer to here. So high will be pointing to 2. So high will be pointing to 2. Then we need to compute 5 into 2, 10. It is greater than. Then we need to move the high pointer to here. 5 into 1 will get 5, and we need to stop iterating. We need to stop binary search, and we need to add these four numbers. The length of the array minus the index which we are getting, nothing but high, m minus high, or you can track the index by using an extra variable. So we need to add this m minus high to the array. Let me implement the Java solution for this. At first, I will take two variables in order to store the length of the arrays given. So after doing this, we need to take an array. So this is nothing but the array which we are supposed to return. So length of the array will be the length of the spells because we are multiplying uh, the numbers in spells with the numbers in portions. And now what we can do is we need to iterate over the array I mean spell I less than n I plus plus. So I will declare a variable called count. I will initialize it to my because uh, we need to add this count to the answer array. I am using this to count the number of variables which product is greater than success. Why I initialize it to m? Remember, we need to remove the elements which are not. I mean, in order to get these elements, we need to subtract from the whole array with index. For that, I am using it, and I will initialize the low variable to 0 and high variable to m minus 1. Nothing but the last index of the portion array. Now I will start doing binary search. While low less than or equal to high, at first we need to compute the mid. Int mid equal to low plus high by 2. So remember we need to compute the product. So how we can do is mm, spells. Actually we need to convert the product into long y because we will get the biggest integer. I mean biggest number which is greater than the integer. So we need to use the long data type. Spells of I into portions of mid. If it is greater than the success, then we need to oh, so remember if it is if any particular number is greater than the success, we need to decrement the high. I mean we need to move the high pointer to mid minus 1. So what we need to do, we need to store the that particular index to here, count equal to mid, and we need to move it to, I mean we need to move high pointer to mid minus 1. Otherwise we need to move the low pointer to mid plus 1. So after the loop, we have to add the count of the numbers into the array, answer array, nothing but. So answer of I equal to m minus c. So at last we need to return answer array. Let me run and check. We are getting some error. Oh, it's a typo. spells. Sort the portions array.